Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to Demystify with Ajay. Today in this session, we are going to discuss on indexing, slicing, and reshaping using NumPy. Let me just start with indexing and slicing. Dear friends, elements and subarrays of NumPy arrays are accessed using the standard square bracket notation that is also used with the Python list. Within the square bracket, a variety of different index formats are used for different types of element selections. And in general, the expressions within the parentheses, which we just say as tuples, where each items in the tuple is a specification of which element to select for each axis, that is the dimensions of an array. And let me just start with the one-dimensional array. And here, dear friends, along a single axis, integers are used to select single elements, and so-called slice are used to select ranges and sequence of elements. And in indexing, positive integers are used to index elements from the beginning of an array, which we just say index starts from 0, and negative integers are used to index elements from the end of the array. So where the last element is indexed with -1 and second to the last element is -2 and so on. Okay, let me just start with some demonstration indexing and slicing operations for NumPy array. Okay, so let me just consider an array with a single axis, that is a dimensional, that contains a sequence of integer between 0 to 10. And so here we have just specified 0 to 11. Obviously in the previous session itself we have just discussed, when we just provide with a range, here the first parameter it just includes it, and where the second parameter it not includes to that of range. So n-1 as it's so. So here, the exact integer, sequence integer, that would be between 0 to 10 here. So here it's so, kindly just have a note of it, and let me just see what are all the elements there in array. So see here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So totally we are having 11 elements. And note that the end value 11 is not included in the array. So to select specific elements from this array, for an example, the first and last and the fifth element we can use as like indexing. So here we have just given that example. The first one is the first element, also which is just say indexing, it just starts with 0. So here it is what the first element, which we just get it from 0. And the last element, which another way it just said as backward indexing. This forward indexing and the backward indexing we have already seen and discussed in Python list. And I just provide the descriptions also to that link. Kindly have a view of that. Here when we just go towards the array, here it is asked like from the last element. So here we are just making it as a negative. So here when we just go towards -1, it is the last element. And obviously as said, if you just provide the -2, it is the last second element. Okay, so that is how we just make use of it. And here if we want to select the fifth element, and kindly have a note of it, the fifth element is which we just specify as to that index, it is as fourth, that is 0, that is index of 4. So what we just receive is the element 4. And next coming is the slicing. And dear friends, slicing are specified using the colon notation, and that is used for Python list. In this notation, a range of elements can be selected using expressions like m:n, and which selects elements that is starting from the index m and ending to that index n, and kindly have a note of it, it is n-1. So note that the nth element is not included. So here the slice m colon n, here when we just make use of this, kindly have a note of it. What I'm just specifying is as m colon n. And yeah, dear friends, when this exact slice m colon n can also be written more explicitly as m colon n colon 1. And yeah, where the number 1 specified that every element between n and n should be selected. And yeah, you can also change the number. Yeah, if you just specify to select second element between m and n, yeah, you can make use of m colon n colon 2. Yeah, we are also having the examples here. To select every p element, use m colon n colon p. That is what the exact syntax format. Okay, so yeah, if p is negative, elements are returned in reversed order and starting from m to n plus 1. So kindly have a note of that also, dear friends. Okay, so let me just start with the slicing, and here to select a range of element, and say here we want to have a second to second last element. Kindly have a note of it. Second to second last element. So here second is the index 1 and second last, and kindly have a note of it. If we specify minus 1, yeah, as to that n minus 1, it is just going to be the second last. So here, so we just get, we are not included with the 0 and the last element 10. So yeah, we can use index slicing. That is what here we have just specified. And kindly have a note of it, dear friends. Here we are provided with the value 2. And in the 7th cell, we didn't provide the colon 1, where defaultly it is specifying 1. And when on just providing this towards the number 2, yeah, as I have specified, to select every second element between m and n, you can make use of the m colon n colon 2. So here, obviously the same above example here with inclusion of the second element. So this is how you can just make use of it. And yeah, dear friends, to select the first 5. So here I didn't provide the first initial value. So here, yeah, as the initial value is not given, yeah, it is going to select defaultly from the beginning. And kindly have a note of it. The next one, I didn't provide the last one. That is, it is just going to select, that is, access every element till end. And if I didn't provide anything for the first and to the last, yeah, defaultly, it is just going to take each single elements. So all the elements, it is just going to have it. So let me just see one by one. Yeah, this is what the first 5 element here we are just going to select. So from the beginning, it is just say, so from the beginning. So here the value of m is not provided. So here it's so first 5 letters, 5 elements here we just got. And to the next one, last 5 elements from an array. And this is happening, see, when we can use this slice, this one. So colon 5 and minus 5 colon are just made use of as like omitting the one from the beginning, and here in the next cell we are omitting the ended. Okay, so as default, the beginning and end of the arrays are the one which we have not included. So that is what avoided. Okay, next one coming here, dear friends, the reversing order. Obviously, here I'm just going to give you an example of a reversing order, and kindly have a note of it that reversing orders is also here. It is specified in the manner of -2. -2, it is the ones every second value. Okay, so every second value we are just going to get it. So complete from the list, from the starting till the ending, it is just going to have it in the list. And yeah, when on just making it towards the reversing, it is only giving us only the every second element. Okay, fine, dear friends. Let me just move on to the multidimensional array. And with multidimensional array, elements selections like those introduced in the previous sections can be applied on each axis. That is what the dimension. But the result is a reduced array where each element matches the given selection rule. Here a specific example, kindly have a note of it. Here I have just given one example where we are just going to have it in a two-dimensional array. And that two-dimensional array, we are going to have it in the format of this function. And yeah, it is going to be in the dimension of 6 into 6. So my exact two-dimensional array, it is of 6 rows and 6 columns. And yeah, we are just going to output it, that is display it by using this yay. So let me just execute one by one. So kindly have a note of it. This is what it is just going to extract the function, and with the function it is displayed. And here we are having it as like from the function, we are just having the array A, that is an uppercase A, where we are just having, kindly have a note of it. Each and every rows, it just has a 6 element, and yeah, obviously we are having 6 columns too. Okay, so now let me just make use of the indexing and slicing here in this two-dimensional. So we can extract columns and rows from this two-dimensional using a combination of both slicing and integer indexing. So let me just see one by one here, dear friend. So kindly have a note of it, what we are having here. A, it is our current two-dimensional array. And here if I just want to select only the column, and here I'm just specifying the second column. Second column, obviously, yeah, the index starts with 0. When I just specify 1, it is all about the second column. And kindly have a note of it. Every format, whichever we are just providing it in this combination, it is all about rows and column. And here for the rows, I just need every row combination. So I'm just omitting it by providing only the colon. And to the same next one, I just need only the extractions of omitting of the second row. So here I have just provided in the column space, I have just provided the colon. Okay, let me just execute this one. Kindly have a note of it. I just want to extract only the column. Every element in a row, that is the exact column. So kindly see here 1, 11, 21, 31, 41, 51. So yeah, from the complete two-dimensional array, I just have extracted only the second column. And yeah, kindly have a note of it. By applying this row column colon, okay, row column comma colon, and here I just specified the row is 1. Yeah, obviously we are just going to select the second row, and kindly have a note of it. This is what the second row I have just specified in the 14th cell. So among this, yeah, we are just going to extract that only. So only that row. And kindly have a note of it, dear friends. By applying a slice on each of the array axis, yeah, we can extract sub-arrays. Yeah, sub-arrays, it is what we just say, sub-matrices in this two-dimensional array. Obviously, let me just have the exact functionality of this. So here, let me just give what is A, so that it would be fine for us to have a review look. And kindly see here, I just need to extract only the upper half diagonal block. Upper half diagonal block, it is exactly, kindly have a note of it. This is 0, 1, 2. And yeah, it is not going to have this 3 and 4 and all. So till this, so 20, 21, 22 would be there, 10, 11, 2, 12 would be there, and the first row of 0, 1, 2 would be there. So this is what the upper half diagonal block. And obviously I'm just giving here the specified dimensional as 3 and 3. So here it is all about 3 into 3 matrix of the upper block. So kindly have a note of it. And towards the things, so here not only the lower, it is all about left of diagonal. So left of diagonal, a small changes we have to do, that is one line only thing. The row I have to specify after 3. Yeah, we know that this exact two-dimensional, it is all about 6 into 6 matrix. So if we want to take only the lower 3 into 3, yeah, we have to specify the row exactly after 3, and to the same here the 3 into 3 matrix. So kindly observe what is the output here. So obviously you would just able to know this is 30 and 31, 32, here it just comes, and 40, 41, 42, and yeah, 50, 51, 52. That is what we just get. And yeah, see here dear friends, if you just make a small changes within this that colon, before the colon and after the colon, that is what which we just say the slicing. Yeah, if we just varies whether would you just inclusion of the rows or inclusion of the columns. So it is all about the selection and slicing of the submatrix. Okay, now let me just move on with the spacing. So kindly have a note of it dear friends. So with element spacing other than 1, so submatrix made up of non-consecutive elements can be extracted. So exactly see here, this is row from the beginning and the column till the end, we are just going to have it. And here I have just given 2. So obviously it is all about the second, that is not the consecutive of the second element, every second element. And here also to that of column, it is from everything, and to the m and n column, and yeah, here also the second element from it. So once on executing, you would be observing. Yeah, before going to that, so let I just give the A to have a small very fine look. So here kindly have a look of it. So see 0 to 4. So here, yeah, obviously we are just getting 0, and this is 2 and the 4. This is what we are just getting. And kindly just to see the next consecutive thing, the second row is not at all selected. And when I'm going to the third row, yeah, there also the alternative as like 20, 22, 24 has been selected, and the next fourth one, no rows is selected, and to the next one 40, 42, 44 is selected, and last sixth row is not included. So this is how you can just make use of. So kindly just give a combination of m and n and with the consecutive elements which you want to be extracted. So give so many examples and have a look, and just check how the exact element which you are just extracting, and how the exact look of the array is making its changes. And yeah, last but not least, let me just have one more selection of this element. So here what I just made it, every second element, and yeah, here I have just missed one small comment. It is every third element that is starting from 1, 1. So see here, this one, it is towards the every second element, and here it is of every third element starting from 1 to 1. So kindly have a look of this 20th cell. This is what our main array, and when we just make use of this, so what we just get is this is 11 and 14. And coming to the next one is 31 and 34 and 51 and 54. So this ability to extract a subset of data from the multidimensional array is a simple but very powerful features with many data processing applications. Let me just move on to the next one. It's all about views. Dear friends, subarrays that are extracted from array using slice operations or alternative views of the same underlying array data. That is, they are array that refer to the same data in the memory as the original array, but with a different strides configurations. So when element in a view are assigned new value, the value of the original array are therefore also updated. So here kindly have a look of it. So this one, yeah, we are just going to have that A here. Kindly let me have what is A here. Okay, from this A, we are just going to extract and make use of the slicing. Okay, we are just going to extract some columns and rows here, and that exact extracted would just going to form it as like another array. Okay, so which we just say as like a subarray, and kindly have a note of it now what this B looks like. So it is all about 11, 12, 13, 14 and 21, 22, 23, 24 until it just makes the 41, 42, 43, 44. Obviously, dear friends. So it just excluding of the first row, last row and first column, last column. Only the inner part it just extracted. And kindly have a note of it. If you want to know what it is there, every element that have here it is a 0, and see, this is what we have already seen towards the A, and from here kindly have a note of it. Now whatever B there extracted as a B, now we are just going to make some more functionality. So here assigning new values to the element in an array B, which is created from array A, also modifies the value in A, since both arrays refers to the same data in the memory. So the fact that extracting subarrays results in the view rather than the new independent array eliminates the need of copying data. So kindly have a note of it. Now we have just done everything in the B column, B two-dimensional array as 0, and when we just make looks towards the A, whatever the changes we have done in the B was now updated. And yeah, the fact that extracting subarrays results in views rather than new independent arrays elements. The need of copying data and improves performance. That is what we are just going to make it in the further cells. Okay, so when a copy rather than a view is needed, the view can be copied explicitly by using the method copy. And yeah, it is all about the copy of this n-dimensional array. So here kindly have a note of it. Now yeah, we are having the B, so let me just have what is there in the B now. Okay, so here we are just going to have the B. Yeah, it is obviously all things are in 0. Yeah, now I just want to convert this B. Okay, now I want to copy the B towards the C, and kindly have a note of it, only the selected array, and here also the C is a subarray of B. Okay, so what is the subarray? It is yeah, we are just going to have as like the same here in 4 to 4 matrix. We are just going to extract the first row, first column, and last row, last column. So now what we have in the C, so see here 0, 0, 0, 0. So this C, it is exactly a 2 into 2 array. And now I just want to explicitly make a changes in this C, and I'm just making it towards every element in the C to 1. And obviously you can just see what is the difference it happening. So now once after converting, kindly just check my array. Yeah, it is all 1, 1, 1, 1. And see towards the exact, I just scroll up slowly above. So here what we have just done, we have done here, that is we just got a subarray from A and we specified it as B. And here in 26th cell, we have converted every element value towards 0. And when I'm just looking on to this A, yeah, the B element, which is the sub array of that alone, is updated as 0. So now let me just make this method by using copy, and kindly have a note of it what is there in B. And to be surprising, by using this B, it is always zeros only here, even though we have made it explicitly to converting that C zeros to ones. It is not updated in B. So that is what the exact difference between the copy. So in addition to the copy attribute of this n-dimensional array classes, an array can also be copied by using this np.copy or equivalent. And here by using this np.array function within the keyword argument, we can just make use as like copy is equal to true. So that is also the alternative method for using the copy. Now let me just move on to the Boolean valued indexing. Dear friends, in this previous section we have looked onto the indexing that is the NumPy arrays with integer and slicing, and here to extract individual elements or a range of elements. And NumPy provides another convenient method to index array, which we just say called as like fancy indexing. And here this with fancy indexing, an array can be indexed with another NumPy array, which can be as like a Python list or a sequence of integer, or whose values select elements in the indexed array. And to clarify this concept, let me just consider an example here. Yeah, kindly have a look of it. We first create an NumPy array with 11 values, and kindly have a note of it. We are just creating it with a line space. And yeah, dear friends, we create this NumPy array with 11 floating point number and then index the array with another NumPy array. And yeah, that NumPy array, which we are just going to index it as like with the Python list. And to extract that element, we have to use that numbers as like a 0 or 2 or 4. That is what we are just going to see. This. Okay, fine. Let me just start with the creating of a NumPy array. So kindly have a note of it. So this is what the NumPy array, it is created, and here it is what's the array indexing. And kindly have a note of it here. The same thing can be accomplished by indexing with a Python list. So I'm just going to give this Python list as 0, 2 and 4. And obviously, yeah, here you are able to see the exact, kindly observe the cell 34 and 36, how it has been indexed by using the fancy indexing. So here, even though we are just getting it 0, 2 and 4, yeah, we are just getting it as to that of values. And the same thing can be accomplished by indexing with the Python list. And this method of indexing can be used along with each axis, that is the dimension of a multidimensional NumPy array. It requires that the element in the array or list used for indexing and integers. So let me just see it with few Boolean valued indexing. So see here, dear friends, here I just want to provide one thing. So this exact indexing, what is just making? Let me have another variant of indexing, that is NumPy array. It is used as Boolean valued index array. And here in this case, each element with the values as like true or false, that going to be indicated whether or not to select the element from the list with the corresponding index. So that is, if element n in the indexing array or Boolean value, it is true. Okay, so then element n is selected from the indexed array. If the value is false, then element n is not selected. So this index method is handy when filtering out elements from an array. So for an example, to select all the elements from the array A, which we have just described in the previous one, okay, so that should be exceeded with a value. Here, see here, we are having the value as 0, 0.2 and 0.5, sorry, 0.4. And if I just want to select all the elements from this array and that exceed the value 0.5. And kindly see, we can use the exact combination of comparison operator applied to the NumPy array and indexing using a Boolean valued array. So see here, we are just using this array and here we are making use of a comparative. And when we just make use of this as 0.5, kindly see it is not there towards the value. So when I'm just making it, so see here, the value which is greater than 0.5, that is alone here it is specifying with the true, true and true. And do you want to know what are all the exact value that is there exceeding 0.5? So here it is the value. So see here, it is 0.6, 0.7, 0.8, 0.9 and to that last one. Unlike arrays created by using slices, the arrays returned using fancy indexing and which we just say Boolean valued indexing are not views but rather new independent arrays. Nonetheless, it is possible to assign values to element selected using this indexing. Okay, let me just create a same thing. So here I just want to create an value. Here A is an array and it is just going to have 10 elements. So kindly have a note of it. So with the function A range, I just having a 10 element. And when I'm just making this 10 element, kindly observe, dear friend, here I just want to make the selection of indices which it just makes 2, 4, 6, and this is another array manner. Okay, and when I just want to combine this towards the another array, which one? This indices. And here I have just given the value of 2, 4 and 6. And when on making this, kindly have a note of it. This is what our B element, that is B array. And if I just explicitly provide -1 towards the index, that is 0th index, that is the B's first value, and it is not going to affect A. Here we are not just making it towards the view. So kindly have a note of it. It is not as like a view here. Okay. So yeah, when we just make use of this, now kindly have a note of it A. And even though if you want to just make it as -1, even kindly have one more overlook towards A. And when on just making this, what it happens, kindly see, here with the indices of 2, 4 and 6 alone, we are able to see the changes. This is 2 and the 4th element and the 6th element. We are doing it towards the specified list, that is specified list elements. Yeah, now here we can just make it use of the Boolean functionality by using true or false. Yeah, let me just have the same 10 element, and here we are having the A is equal to 10. So sorry, yeah, an array A has 10 elements. Okay, and kindly have a note of it. What is this? The B, which is going to have an array of the elements from A, and that A, it is greater than 5. So we are having 3 combination. Kindly observe, dear friends. The value A, which is greater than 5, we're just going to have that as like an array, and that we are making it towards the B. Okay. Now if you want to know what is there in B, so kindly have a look of it. What's in B? Okay. So here that is greater than 5. So 6, 7, 8 and 9. And kindly have a note of it. Again, we are just going to have b of 0, 0th element is equal to minus 1. So in this particular thing, okay, so this is not going to affect the a. Yeah, of course, we have already specified that this exact value, it is not asked through the view functionality. And see here, dear friends, when on just making this 51, the conversion, that is the B0, we have just converted it to minus 1. So it is not going to be there towards the A. The A, it is going to be as it is. But when I'm just going to make here a combination of A that is greater than 5 of the element A should be minus 1. So what it has going to happen? So obviously, yeah, I just remove above. So A that is greater than 5, it is the element as like 6, 7, 8 and 9. So kindly have a look of it in 49 and 50. I'm just making a small note towards it. It is not the exact one. Okay. So here A greater than 5, the element which has the value that is greater than 5 is 6, 7, 8 and 9. And that is indexed towards A. So if it is true, yeah, that exact indexes towards A, array A, I want to convert it to minus 1. And once for all, so before converting, so this is what the A, so we are having 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and once after the true functionality, and now kindly have a note of it. So what you have observed, the exact value that is more than 5, sorry, that is greater than 5 is converted to minus 1. Yeah, now let me just move on to reshaping and resizing. Dear friends, when working with data in array form, it is often useful to rearrange arrays and alter the way they are interpreted. For an example, an n into n matrix array could be rearranged into a vector length of n square, or a set of one-dimensional array could be concatenated together or stacked next to each other to form a matrix. And here the NumPy provides a rich set of functions of this type of manipulation. So let me just make use of it one by one. And here it is what all about reshaping an array. And it does not require modifying the underlying array data. It is only changes in how the data is interpreted by defining the array's strides attributes. Here, an example of this type of array, if we just kindly have a note of it, if we just take 2 into 2 matrix, okay, so that is interpreted as 1 into 4. So here we are just going to have as a 2 into 2 matrix, okay, and yeah, by using the NumPy function and here by using the reshape, we are going to convert it, okay. So we are just going to convert the dimensional of that array. So how we are just going to make it? Yeah, let me see it by one. And here it is what the dear friends. So the data which we are having. So kindly let me just see what the data has. So it is all about a 2 into 2 matrix, and yeah, its element is 1, 2, 3 and 4. So 1, 2 is in single row and 3 and 4 it is in another row. And kindly see here, dear friends, I just want to reshape that data. Which data? The 2 into 2 matrix data. And by using this reshape method, it is reinterpreted as 1 into 4. So here I have just given how to modify this one, the source of the data, and here the reshaping measurement. And obviously when we just created it, it is all about 2 into 2. So the first row 2 elements, second row 2 elements. That is what we have just given through the list. And when I'm just making this reshape, kindly observe, dear friends, how it has been done. So everything, it has been done by using this np.reshape. And this exact method can be used to reconfigure how the data is interpreted. It taken an array and the new shape of array are done with this argument. And kindly have a note of it, dear friends. It is necessary that the requested new shape of array match the number of elements in the original size. Here, however, the number of axes, which the dimension does not need to be conserved, or as illustrated above, here we have just done as 2 into 2, but where in this first case, the new array have 2 dimensional and the shape 1, 4, while in the second case. Okay, so the new array, it just has dimension 1 and with the shape of 4. So this example also demonstrates 2 different ways of invoking the reshape operations. Okay, so let me just make use of the another functionality. So see here, dear friends, this is how you can just make use of the reshape of 4. This is also can be done. Here you are just going to give only the exact element, that is the shape 4. And here that not the shape, reshaping an array produces a view of array. Kindly have a note of it. And if an independent copy of the array is needed, the view has to be copied explicitly by using np.copy. Now let me just make use of another alternate. And kindly have a note of it, dear friends. This one which we just say corresponding n-dimensional method, and it is a special case of reshape which collapses all dimension of an array and return a flattened one-dimensional array. And here it is so. So see here, dear friends, with the length that corresponds to the total number of elements in the original array, that is what it's just going to return it, that is flattening it. And yeah, this method flatten performs the same function but returns a copy instead. Kindly have a note of it. Okay, it is copy instead of a view. So here let me just create an array of data. So here, yeah, you are able to know the data. It is all about 2 into 2 matrix. And when you just make it a simple thing, flatten, if you didn't know how many elements are there or how many number of elements that is provided in the format of matrix, yeah, if you don't know, just flatten it. And even though you can just view over the shape of that. So see here, it is a single one line thing. Okay, and yeah, it just shows us the 4 elements there in this array. Dear friends, this np.flatten, so that is np is in the sense that is the NumPy which we are just having that source, and to that of flatten function, it just collapses the axis of an element of an array into a one-dimensional array. It is also possible to introduce a new axis into an array. So either by using np.reshape or when adding a new empty axis or using index notation, and even though you can just make use of a new axis, that is what we are just going to see it next. Kindly have a note of it. So this is how, let me just create an element. Okay, and this exact element, how we have just done it is, yeah, if it is as like an tuple, that is with more than one element, and if the extra indices in the tuple have value, so we are just going to make use of new axis. Okay, and let me just make use of it by starting it. So let me have what is there in the data. So kindly have a view. So we are having 0 to 5. So this is 0, 1, 2, 3, 4. We have just provided. Okay. And with this, kindly have a note of it. I just want to change it towards the axis. The data, which here I'm just going to make it towards the axis. See, obviously we know this is in a row wise and I want to change it towards the column wise. So that I have just given this variable column. So don't get confusion. So here it is only about the name of the variable. Okay. So here kindly observe when I just provide this new axis and kindly view the resultant. So how it has converted. And even though the same data, now if you want to convert it towards row, which is now as like a column. So see here, I just want to make it towards the row. So here, if you want to specify it towards the row, yeah, you have to give in the first coordinate, and if it is on the column, kindly just provide it in the second coordinate. And yeah, let me just view one more functionality, and kindly have a note of it, dear friends. The exact we have now looked at methods to rearrange array in ways that do not affect the underlying data. But earlier in this session, we have looked how to extract subarrays using various indexing techniques we have just discussed. And in additional to reshaping and selecting subarrays, it is often necessary to merge arrays into bigger array. But for an example, when joining separately computed or measured data series into a higher dimensional array, such as like a matrix. And for this task, NumPy provides the function called vstack for vertical stacking. And this, for an example, if we just want to make rows into a matrix. Okay, and here one more is there, hstack, which is for horizontal stacking, and for example it is all about columns into the matrix. And yeah, last but not least, let me just see it with that functionality. So see here, dear friends, we are just going to have a data, and yeah, with that we are having 5 elements. And this exact, the shape of array passed to the hstack or vstack, okay, which is important to achieve the desired type of array joining. And see here, dear friends, here what we have just given this data is a one-dimensional array of data. And we want to stack them vertically to obtain a matrix. And when the rows are made up of one-dimensional, yeah, we can use it towards this vstack. And kindly have a note of it. I want to make it data, comma, data, comma, data. So here what it's just going to have, yeah, this exact vstack vertically I want to concatenate with the data, next one more row, I said one more data, next one more data. Is it want to view what is the exact resultant? Exactly, dear friends, kindly have a look of it. Each and every single dimensional, now it is converted it into a matrix of 3 rows and 5 columns. Yeah, now let me just make it. If we instead want to stack the array horizontally to obtain the matrix, and here it's so kindly have a view of this. So here also we are just going to make the same data, and it is a one-dimensional. And kindly see here, this data, what we are just going to make it is as like hstack, and this is column, comma, column, comma, column. Okay, so kindly have a note of it. It is all about in a single thing. So this is the data, and next column it is all about the second data, and next it is just be the third data. Yeah, obviously I am able to understand what you expected. Yes, dear friend, if you want to make it towards that in the matrix format, yeah, it has to be done towards the index stack and array horizontally. So, but not in the way of intended here. Okay, so here to make this horizontal stack, okay, the treat input array as a column and stack them accordingly. And here we need to make an input dimensional as like 2-dimensional, and the shape as like 1,5 like that. Okay, so let me just have this, kindly have a look of it. And when I just provide this, yeah, what you observed is the ones, or what you expected it is what here. So here, kindly just to see this single dimensional array which we have specified in the cell 74, now it has been as the first column, and it is what the data here. And next one, it is the second data, second column, third data, third column. Obviously, everything are the same element. And dear friends, hope I think so this exact learning on indexing, slicing and reshaping was much interested, and hope dear friends I have given you more input. And yeah, kindly have so many examples by changing the coordinates of indexing and changing the coordinate of slicing. There the learning would be much more interesting. Okay, so kindly subscribe the channel and never miss any updates. Happy learning dear friends. Thank you. Bye.